Hi, engineers. Want to practice more challenges for your next coding interview? Let's tackle one of the most common interview problems, merging sorted arrays. We'll keep this practical and beginner-friendly, then step up to the optimal approach. Today, we'll write two solutions line by line, the simple glue and sort, and the classic two-pointers. We'll finish each with quick console checks and a short complexity note so you can say it confidently in an interview. Let's say the problem out loud. We are given two arrays, both already sorted in non-decreasing order. Our job is to merge them into one sorted array. Imagine two tidy lines of numbers. We are weaving them together without breaking the order. Let's rephrase it in plain English. We look at the front items of both lists and always take the smaller one first. We keep doing that until one list runs out, and then we append whatever is left from the other list. Simple and predictable. First, let's set up three example inputs so we can test later. We create a variable named A1 as the list of 1, 3, and 5, and a variable named B1 as the list of 2, 4, and 6. Then, we create a variable named A2 as the list of 1, 2, and 2, and a variable named B2 as the list of 2 and 3. And finally, we create a variable named A3 as the empty list and a variable named B3 as the list of -3, 0, and 7. How do we solve it the beginner way? We take both arrays, glue them together, and sort the combined result numerically. This is fast to write and easy to explain, but it is not the most efficient. Let's create a function named mergeSortedSimple that takes two inputs named A and B. We will return a new sorted list. Inside the function, first, we create a variable named combined and set it to A concatenated with B. Next, we sort combined with a numeric comparator. We write a sort that compares two numbers x and y by returning x minus y. That forces numeric order instead of string order. Finally, we return combined. Now let's test this beginner version with our variables. First, we write a console log of mergeSortedSimple of A1 and B1. Next, we write a console log of mergeSortedSimple of A2 and B2. And finally, we write a console log of mergeSortedSimple of A3 and B3. When we run the code in the terminal, we should see 1, 2, 3, 4, 5, and 6 for the first one, 1, 2, 2, 2, and 3 for the second, -3, 0, and 7 for the third. Complexity for this version, time, O of n plus m log of n plus m, because of the sort, space, O of n plus m for the new array. Now, the approach most interviewers want to see. We will use the classic two-pointers technique. It is fast and stable. We keep one index for each array. We compare the current elements, push the smaller one into the result, and move that array's index forward. Because both arrays are sorted, the smallest overall element is always at one of the two heads. Doing this in one pass keeps the final array sorted. Here is the solution, line by line. Let's create a function named mergeSorted that takes two inputs named A and B. We will return a new sorted list. Inside the function, first, we declare a variable named I and set it to 0. I points to our current position in A. Next, we declare a variable named J and set it to 0. J points to our current position in B. After that, we declare a variable named result and set it to an empty list. This is where we will push merged values. Now we start the main loop. We create a while loop with the condition I is less than A length and J is less than B length. This means both arrays still have items to compare. Inside the loop, we write an if statement to compare the current elements. If A at index I is less than or equal to B at index J, we push A at I into result, and then we increase I by 1. Otherwise, we push b at j into result and increase j by 1. We use less than or equal for stability. Equal values from a will appear before equal values from b, preserving original ordering for ties. After the main loop finishes, one of the arrays is fully consumed. We might still have leftovers in the other array, so we add two small cleanup loops. First, we create a while loop with the condition I is less than a length. Inside it, we push a at I into result and increase I by 1. Then, we create another while loop with the condition j is less than b length. Inside it, we push b at j into result and increase j by 1. These loops append any remaining elements. Finally, we return result. That is our merged, sorted array. Let's test the two-pointer version with the same variables. First, we write a console log of merge sorted of A1 and B1. Next, we write a console log of merge sorted of A2 and B2. And finally, we write a console log of merge sorted of A3 and B3. When we run the code in the terminal, we should see 1, 2, 3, 4, 5, and 6 for the first one. 1, 2, 2, 2, and 3 for the second. -3, 0, and 7 for the third. Quick complexity note, you can say out loud. Time, O of n plus m, where n and m are the lengths of the two arrays. We touch each element once. Space, O of n plus m for the output array. If an interviewer asks for in-place merging into a pre-sized first array, mention a three-pointer variant from the end. Write the larger tail first. Otherwise, this result array version is the clean, beginner-friendly answer most interviewers accept when no in-place constraint is stated. Tiny edge case checklist. Either array can be empty. The cleanup loops handle that. Duplicates are fine. Less than or equal keeps ordering stable. Negative numbers are fine. Comparisons work exactly the same. Wrap up. Solution 1 is the beginner, glue, and sort. Quick to write, slower due to sorting. Solution 2 is two pointers, linear time, steady, and predictable. Once you can narrate, compare heads, push the smaller, advance the pointer, then append the tail, you can code this live without stress. Now you're 1% smarter. The cheat code is consistency, so keep boosting your brain. Make it your daily routine, and you will nail your next interview. Same rhythm tomorrow at Code Crack Interviews.